stock using linked list. So when you take linked list, we have already done this, and stock using linked list is very simple program because we have already done linked list programs. Now assume that there is a list already. Sorry, we'll take a singly linked list. Normally we go for singly linked list, not doubly linked list. So I'll take singly linked list. Because doubly linked list is not required because insertion is done only at one end. Now this is the linked list. Suppose if this is 25, 30, 22, suppose if these are the data items present. And the important thing with stock using linked list is top will be there, and top is referring to the recently filled data item. Top is instead of in singly linked list, we used one reference called start. Instead of start, we use top. Top will be always referring to the recently filled item. So this is one important thing. The second thing is now insertions and deletion. Push is done here, pop is done from here. That is one important thing. So in linked list, what we have done, insert at beginning, insert at beginning. So insert at beginning is nothing but push. So insert at beginning is nothing but push. So insert at end, insert at after given node is not required. So insert at beginning, we can change it as push. So the logic is simple. So to insert at beginning, what we have to do, create a node, read data, suppose 33, read data. Then this will be none. We need not make it none, in fact, because it will be always inserted at the beginning. So what we have to do now, this is ND. So ND dot next. So this should be the first node. So ND dot next equals to top. That means this will be referring to this. And now ND dot next equals to top, and top equals to ND. So these are the two statements. Now top is no more referring to this, and it is referring to this. So insert at beginning is very simple, and even suppose if the linked list is empty, so this is none. When we create a new node, this is ND, and there is suppose data of 44. ND dot next top, so which is none, and so the next node is none because it is the first node. Now top equals to ND. Top equals to ND. That means now it is not none. This is referring to this. So push operation is very simple operation. It is nothing but insert at beginning. So this is the push operation. Now we'll write the algorithm for push operation. So if I take the algorithm for push operation, so step 1 is read data. Step 2, create node. Step 3, move data into node. Step 4, these two important steps. So these two are the important steps, key steps. So step 4 is ND, make, because ND we are not using anywhere here, make a new node. Next, refer to top. Step 5, make top refer to new node. So this is the algorithm. Push algorithm is very simple. So we have to create the node, move data, and make new node next refer to top, and make top refer to new node. So this is the push algorithm. It is very simple. Now, when I take the pop algorithm, it is also very simple. Pop algorithm. So if I take the linked list like this, so top will be referring to this. This is 50, suppose 75, 22. This is referring to this, and this is referring to this. Now, normally we delete in Python, we delete. What we delete is delete the given node. So read the data and search for that delete. But here, no such thing. Delete always the first node. So in normal linked list, we delete a given node. So whichever node data of the node given, that node is deleted. But in stock, pop is nothing but delete the first node. First is nothing but top node. Delete first node. So this is the operation. So the logic is very simple. So when I take this, if I want to delete, what we have to do is move data of the node, like top node data into data, then make this top refer to the next node. So what we have to do is top equals to top next. So this is how the operations are performed. But one special thing what you have to do is check whether stock is empty. How do you know whether stock is empty? If top is none, stock is empty. So that is the only thing we have to do. Otherwise, move data, top data into data, and move top to refer to the next. So this is the algorithm. So we'll write the algorithm. So the stock, whether using linked list or array, it is going to be very simple. So if I take the algorithm for pop algorithm, so step 1 is check whether stock is empty. Check whether stock is empty. This is the first step. So if as part of this first step, if stock is empty, display appropriate error message. So step 1.1, display message indicating that stock is empty. Then step 1.2, exit. Don't do anything. Step 2 is, so if stock is not empty, move data part of move data of top node. Move data of top node into data variable, data. Then step 3 is move make top refer to the next node, because now that node is deleted, it is popped. So we have to make top refer to the next node. So this is the logic. Step 4 is exit. So this is the logic, overall logic of stock using linked list. Now we'll see how it is implemented using Python. So the Python implementation of stock using linked list is also simple. So I'll write here. So I'll say stock using linked list. Now, first thing, because it is linked list, create the class node. So initialize the node. Self. So what should be there? Self node. So I'll move data here as usual. So self dot data equals to data. Then self dot next. It is not required, but it is better always to do this. Self dot next equals to none. So because it is going to be always the first node, so it is not required. But even if you don't, if you do it, there is no problem. So this is the node. Whether it is normal linked list or stock using linked list, the class of node remains same. Now I'll say class stock. So I'll say linked stock. Simply to change the name, I'll say linked stock. So here we require the constructor and the starting reference, which is top. So self dot top equals to none. This must be made none to indicate that list is empty. The linked list is empty. Then there is push operation. So self comma data. And when I say push here, what we have to do is, so create the node. So create the node. Creating the node. Then move the data. Then make a new node refer to top. That's what we wrote the logic here for push. So check the logic what we have written. So for push what we have written, make new node next refer to top. So nd dot next equals to top. Nd dot next equals to top, and top equals to nd. This is the simple logic for push. And just we'll say the data is pushed successfully. So print will say the data pushed stock successfully. This is push operation. Now when I take pop self and check whether stock is empty. So that is one important thing. If top equals to none, so print stock is empty and return none, because there is nothing, no data item is present because the stock is empty. Otherwise, what you do is dot data equals to top. So what are the steps here we are writing? Just let me refer that. The first, so stock empty we have checked. Then move data of top node into variable data. So data top node data move into variable data. Now top make top refer to the next node. Top equals to top dot next and return data. So this is the logic of pop. So this is the logic of pop. Now I'll write the main. Main remains same as the earlier one, but still I'll write it again. So define main. First thing is create stock. Stock equals to linked stock. Now I have changed the name, linked stock. Then create the menu while take while loop, while true. So print menu, print option 1 push, print option 2 pop, print option 3 exit, print. So read the option equals to int input, enter your option. If option equals to 1, so you take stock read item. So data equals to int input, enter data to push. Then you say stock dot push equals to data. Else option equals to sorry, here spelling mistake. Option equals to 2. So you pop data equals to pop stock dot pop. So if data not equals to none, print is popped from stock. So this is the menu, and sorry, we had to write the exit also. So else if option equals to 3, data sorry, you say break, else, so print wrong option. So this is the overall code. Here, I think we have to use self everywhere. Self wherever top is there, we have to use self. So that is one mistake I'm doing. I'm modifying this. Self. So this is the code. See, I'm going little bit fast because the code is very simple. Because if you have understood linked list, this code is nothing before that. So I'm execute. I have compiled this main. Now I'll execute. I'll execute this. So push, pop, and exit. So first I'll try to pop. So list should be empty. It should stock is empty, not list. So the message stock empty is displayed. Some spelling mistake. I'll correct it. Now push. So I'll push 22. So some error here. What is that error? We'll check. Data one missing required positional argument data. So I think I'm not passing data here. Push data I'm passing. Here push. What I'm saying stock dot push linked stock. So what is the error required positional argument data? Missing one required positional argument data. Push self dot data. Sorry, here, yeah, correct. Constructor, I had to pass data, so that is missing. So I had to pass data. Okay, I'll also correct the error what I have written, pushed and stock is empty. Somewhere, some mistake popped from stock. What was the mistake? Empty, stock is empty message, I think it's So here. So now I think it's correct. So I should have passed data to the constructor of node. I'm not doing that. So that was the error. I had to data should be passed as parameter, not data should be passed as parameter, but not set here. So I'll correct this. So this is corrected. Now I'll execute this main. So push 1. So 22 is pushed. 1, 33 pushed. 1, 44 pushed. Now if I pop, so 44 should be popped. So 44 is popped. If I pop, 33 is popped. If I pop, 11 is 22 is popped. Yeah, correct. Now if I pop, empty. Stock is empty. So it is getting executed. Fine. There is no problem. So finally exit. So this is stock using linked list. So stock implementation is very simple among the programs, whether it is array or linked list. So because normally linked list is slightly complex, but here the linked list has only one simple insert operation, which is insert at beginning, one delete operation, which is insert at the beginning. So because of these two simple insert and delete operations, the overall implementation of stock using linked list is also very simple. So that is